Alright, so what I'll be doing in today's video is sharing with you some explorations using Grasshopper. This particular pattern is a hexagonal pattern that has this cube-like effect, and I'm showing the whole process here at the beginning by starting with the hexagon, then creating the subdivisions, and then at the end having this pattern. And so you'll be seeing that full tutorial, and I'll also be sharing the work session where I created this pattern, which is the same thing, but it has the subdivided surfaces, and it also has other things that can allow you to use this pattern in your designs, but also share with you other aspects that I might not get into in the tutorial. So hopefully you're excited. I will have this available to download on my website, so go and check that out if you're interested. And I also have other resources if you're interested in learning parametric design. So with that being said, thank you for being here, and let's jump right in. Alright, so for this pattern, I need to start with a hexagon grid. So I'll go here and start with hexagon or hexagonal grid. And now I will plug in here for the plane, a plane input or a point. So I'll go here to construct point. Then I will route it through an empty point component. This way we can always change the location of the pattern. And now with this point, we'll plug that into the plane input. And so that will be the location of the pattern. Now we can change the size. So let's do that. Go here to 50. Extent, that's going to be the array. So let's go here from 1 less than 15. And I'll just create 2 of these. Okay, so now we've kind of set the stage, because since we have the hexagon, we have the base geometry. So starting with getting the midpoint of each hexagon. Now what's funny about this component is that it actually doesn't have the points. Even though you can see that there's points here, it does not display them. So we actually need to bring in an empty point component and plug the points in. And now you'll see that each point is actually the center point of each cell. So now let's connect each corner point to each center point to create the base pattern. Now, we don't need all of them. We only need 3 of them. So what I need to do is go to cells here. I'll go to a component called discontinuity, which is going to give me each point in each hexagon. Now, if I were to take this point and create a line segment between the endpoint, which would be the center, and these points, which would be the start, notice that they're organized in a different way. Well, if we graphed the endpoint, notice that it fixes it. What it's doing is it's organized in a certain way. So when you graph this input, now you have each of those corner points going to just that center point. But what we need to do is, rather than pick all of those points, we're going to just pick 3 of them. So we know there's 6, so we'll plug this in. We have the first one, the second one, third one, fourth one, fifth one, and sixth one. So rather than connecting all of them, now we're going to do the first one, skip 1, and then skip 1. So this creates this subdivision where it's basically taking the hexagon and subdividing it into 3 equally spaced areas. And so now with this, now we have the ability to expand this and create this pattern that's a regular pattern that you've seen that kind of creates these boxes. So now with this, the next step is to take these line segments, new ones, and rotate them randomly. That's what's going to give the effect that I have shown in the thumbnail. So what we need to do now is take these, and now we're going to go here to rotate. I'll plug in those line segments into the geometry, and then the center point is going to be the plane. Now notice that once again, we need to graph the input here. And now we can change the angle. And we can set it here to degrees. And then see that we're actually rotating all of them at once. Now if we wanted to, we need to figure out what the rotation is, and then just do a random set of rotations for each point. So how do we do this? First of all, we know we need more than one number. We know how many we need, 216, but it's actually going to be 72 of the points that are rotated. So those are the random numbers that we need to create. So we'll go here to random. Oh, also, we need to know the angle of rotation. So if we have a hexagon, let's do that. If we have a hexagon, we're going to divide the 360 by B is going to be a hexagon, so 6. If we have 360 divided by 6, that's going to be 60, and that is by how much we can rotate. So now if we take that number and we'll multiply it, so if we have 60 times 1, but here we'll create a slider, let's say with 3, starting at 1. If we do 60 times 1 or times 0, it won't rotate it. Times 1, it'll rotate it by 1, 2, and so on. So what we need to do here is rotate this randomly by 60. So let's see here. We have this one. Here we have the original rotation one and this one. I just had to hide this one. Now you'll see that. Now you can shift. Basically the rotation is between here and the next one. And notice that I can plug in any number here and it's going to rotate it no matter what. So what I need to do now is plug in and graft in 72 different numbers. So what we need to do here now is move this over. The numbers that we need, we'll go to list length, because these are the number of points, 72. If we flatten the list length, will give us a number of how many items I plugged in. Why? Because that's actually going to change if I expand the array. Now with this, I can use that length as the number. Now the range is the range of numbers that I want to create. I want 72 numbers, but it's from 0 to 1. So now let's construct domain. And with this one, we can start at 0 and end at, say, 10. So it creates a random set of numbers from 0 to 10. But notice that it has a bunch of decimal points. So now what we need to do is take those decimal points and round them to the nearest whole number, and then use that to multiply. Now notice that it's still not working, and the reason why is because all of these are dashed, and then this one is not dashed, which means it's just one long list, which we actually need to graft. And by doing that, now we have all of those random rotations happening here, and we can change the seed. So if I go to 3 here, we can actually change that. And so that's the basics of this pattern. It is setting the stage in terms of creating the hexagon, creating the truncated subdivisions with the center point, and then using that exact same point that we used to rotate to randomly rotate multiples of 60 this way. We could eventually have a bunch of random rotations to create this pattern like this, which in turn you'll see at the end. And so what I did is at the end here, I created a full tutorial where I show you how to take that pattern, turn it into surfaces, and randomly or set 3 different colors for this. So it could look something like that, or adding some color like this one, or even just a single color like that one. So just wanted to share with you guys the script and the tutorial, and let me know if you have any questions. My idea here is to continue the exploration of using parametric tools like Grasshopper for architecture, or even for exploring new patterns like this one. So hopefully you're excited and learned something about this. And if you have any questions, let me know in the comments below. I'll have this available on my website for you to download if you want to check this out and see how it all plugs in. And I also have other resources that can help you if you're interested in parametric design.